Welcome students to this series of lectures on statistics, and this is lecture 9. In the last three lectures, we have discussed probability, and this is also the third lecture where we are discussing probability. What we are trying to achieve, we are trying to write down all the rules, all the formulae, all the nomenclature, all the terminology that is related in probability. So we'll create a blueprint of probability and we'll use that blueprint to solve the first 10, 15 questions. And onwards, you will develop an intuition to solve any questions of the probability. So the blueprint that we are discussing in the 3 to 4 session of probability is more around helping you solve any questions of the probability, help you around building the intuition that is required to solve the questions around probability, especially for the examination like CFA, FRM, and actuaries. And today, in the third lecture, this is the third lecture, and we are discussing two rules or one rule and one theorem. The one rule that we have to discuss is the total probability rule, and the theorem that we are discussing is the Bayes theorem. Okay, let's get started with total probability rule. As the name suggests, total probability rule. So you're trying to find out the total probability of something happening. So assume that entity is A and you're interested in finding the pure probability of A or the total probability of A or the marginal probability of A or unconditional probability of A, right? Probability of A. This can be called as total probability. This can be called as unconditional probability. This can be called as marginal probability. So this is the purest probability of A. And assume probability of A means A is an entity and A could be any entity. And assume here A is what is the probability of Tesla stock price rising? What is the probability of A, where A refers to A is an entity which refers to what is the probability of Tesla stock price rising? Now, we know that Tesla stock price rising is dependent upon multiple factor. Factor F1, factor F2, factor F3. We are calling factor F1 as B, C, and D. What could be factor F1? Factor F1 or the first factor would be like, okay, the market has risen. So what is the probability of Tesla stock price rising? Because Tesla stock price rising is also dependent upon market. So market is one of the factor. What is factor 2? Factor 2 could be interest rate. So what is the probability of stock price rising or Tesla stock price rising given the interest rate has fallen? Factor 3 could be investment in R&D. Tesla is known to investing a lot in research and development, R&D, right? So that would be the third factor. So what is the probability of Tesla stock price rising given there is a huge investment in R&D, right? So we know that A, which is Tesla stock price rising, is dependent upon factor B, C, and D. And if I'm interested in finding the pure probability of A only, the purest probability of A, the purest probability of A, then I would write it as probability of A is equal to probability of A and B plus probability of A and C, probability of A and D, right? Probability of A and B plus probability of A and C plus probability of A and D, right? Now this. We discussed in the last session, this refers to what? AND rule. If we break the AND rule, then it will become probability of A given B into probability of B plus probability of A given C into probability of C. And you will break it down into probability of A given D into probability of D. That is the total probability rule. We'll see the application of total probability rule with the help of one question. But before that, let's deep dive into Bayes theorem. Actually, this is not a deep dive into Bayes theorem because Bayes theorem need a separate session to be discussed. But for those who are appearing for CFA, FRM or actuarial examination, whatever we are discussing in this video is sufficient to solve any question which is related to Bayes theorem. Okay, so I'm trying to help you remember the Bayes theorem with the help of derivation. So we'll write the derivation and you will understand the Bayes theorem. Okay, so we're trying to derive what? Bayes theorem. So let's write it down. So if I say what is the probability of A and B happening simultaneously? So you would say that this is equal to probability of B and A happening simultaneously, right? Because it is simply asking what is the probability of A and B happening simultaneously. So whether you write A first or B first doesn't matter. If I break it down as per the AND rule which we discussed in the last session, it will become probability of A given B into probability of B is equal to probability of B given A into probability of A, right? Whether you write A first or B first doesn't matter. So it doesn't matter whether you write probability of A given B into probability of B, or you write probability of B given A into probability of A. Doesn't matter. Both should be equal. Now, if you're interested in finding probability of A given B, what you will do? You will throw probability of B into the denominator in the right hand direction. So it will become probability of A given B is equal to probability of B given A into probability of A upon probability of B. But if you are interested in finding probability of B given A, what you will do? What you will do? You will throw A in the denominator in the left hand direction. So now it will become probability of B given A is equal to probability of A given B into probability of B upon probability of A. Okay, I'm writing it again. This is probability of B given A is equal to probability of A given B into probability of B upon probability of A. For the time being, scrap this. So you have two different end result of probability of A and B is equal to probability of B and A. Now this is your Bayes theorem actually. What is happening in Bayes theorem? If you're interested in probability of A, which is in numerator, given probability of B, which is in denominator, and you know what is the probability of B given A, where B is in numerator and A is in denominator, if you want to flip it, you want A in the numerator and B in the denominator. You multiply with the probability of A, which you want in the numerator, and divide with the probability of B, which you want in denominator. See, you wanted probability of B in denominator. Similarly here, if you're interested in probability of B given A, where B is in numerator, A is in denominator, and you know that what is probability of A given B, where A is in numerator and B is in denominator, and you want to flip it, you want to make probability of B in numerator and probability of A in denominator, you will multiply with probability of B and you will divide with probability of A. So this is your Bayes theorem, Bayes rule. Now, most of the expert in statistics would say that, hey, you haven't given the gist of Bayes theorem. I agree. But for the examination, this is sufficient to solve 80 to 90% or 100% of the question in the Bayes theorem, right? Maybe in the next session, we'll discuss about the gist, the real uses of Bayes theorem, why statisticians, why machine learning algorithm experts are so much interested in Bayes theorem. We'll discuss about it in the next session if you are all interested. Uh, Okay, but for today's session, we'll just deep dive into the application of total probability rule and Bayes theorem. So there is a question that the probability that the market will rise is 70%. So what is the probability of market falling? The rest, 30%. If the market rises, please note, it is saying if the market rises, the probability that the stock price rises is 80% and the probability that the stock price falls is 20%. Now the question is this 80%, 20% is unconditional probability or conditional probability or marginal probability. These are conditional probability because it is dependent upon market rising. If the market rises, then the probability of stock price rising is 80%. So it is not pure probability of stock price rising. This is not unconditional probability of stock price rising. This is not unconditional probability of stock price falling because it is conditioned upon market rising. If you couldn't understand this, then your concepts on the probability are not clear. For that, you have to watch the two lectures that are the predecessors of this video. That is session 1 and session 2 in the probability, starting from the roadmap of probability. Okay. If the market falls, the probability that the stock prices rises is 40%. The probability that the stock price fall is remaining probability, that is what? 60%. Okay. Based on the above information, you have to calculate the overall probability that the stock price rises. Now, this is the pure probability they are asking for. They are asking for what is the probability of stock price rising only. So you have to apply which rule? Total rule or Bayes theorem? Total rule. Because total rule will give you the pure probability of something happening, right? You have different conditional probability of stock price rising. You have to find out what is the pure probability of stock price rising. So I would suggest pause the video here, apply this formula. If you're able to apply the formula, then well, good enough. If not, then we'll solve the question. So let's first solve the question of what is the total probability of stock price rising before moving to question number 2. So actually I constructed this question in the form of a tree, probability tree. So the probability of market rising is 70%, the probability of market falling is 30% then, right? Now it is given in the question that the probability of stock price rising given the market has risen is what, 80%? It is given in the question, 80%. And the probability of stock price falling given the market has risen is 20%. Okay. If the market falls, the probability of that happening is 30%. And if the market falls, the probability of stock price rising is 40%. So probability of stock price rising given the market has fallen is what? 40%. Probability of stock price rising given the market has fallen is 40%. Probability of stock price falling given the market has fallen is 60%. Now you are interested in probability of stock price rising. So as per the total probability rule, you need probability of stock price rising given the market has risen into probability of market rising plus probability of stock price rising given the market has fallen into probability of market falling, right? This was the Bayes theorem, correct? Do you know what is the probability of stock price rising given the, sorry, this is the total. Now, this is what? The total probability rule. Sorry, not Bayes theorem. This is the total probability rule. So probability of stock price rising given the market risen into probability of market rising plus probability of stock price rising given the market has fallen plus probability of market falling. So if you write it down, probability of stock price rising given the market has risen. This value is what? 80%, right? This value is 80% into probability of market rising. This value is what? 70%. So 80% into 70%, 80%, and you have 70%. So 80% into 70%. Then you have probability of stock price rising given the market has fallen into probability of market fallen or falling. So this is 40% and this is 30%. So 40% into 30%. So basically you have to do 70% into 80% plus 30% into 40%. This is 56% and this is 12%. So this will become what? 68%. So 68% is the pure probability of stock price rising. 68% is the pure probability of stock price rising. Okay. So we understood the application of total probability rule. Now let's try to find out what is the probability that market has risen given that the stock price has risen. So actually the question is, what is the probability that the market rises given that stock price has risen? So you're interested in finding this. What is the probability of market rising given the stock price has risen? Now you don't have this information. What you're interested in, what is the probability of market rising given the stock price has risen? You don't have this information. See in this tree, you don't have this information. But if you apply the Bayes rule, any one of them, this one or this one, you can flip the numerator and denominator. So let's check. If you don't have this information, probability of market rising given the stock price has risen, do I have the information? What is the probability of stock price rising given the market has risen? The answer is yes. So you're interested in finding the probability of market rising given the stock price has risen, but you don't have this information in this tree. You don't have this information in this tree. See? But if you see carefully, you have this information. What is the probability of stock price rising given the market has risen? Flip this and you have this information. So as per the Bayes theorem, what you have to do? You have to flip the numerator and denominator. What do you want? You want the market rising in the numerator and the stock price rising in the denominator. So for that, what you will do? You will multiply this with probability of market rising because you want it in numerator here, and you divide with the probability of stock price rising that is in the denominator here. So what is the probability of stock price rising given the market has risen? It is 80%. What is the probability of market rising? 70%. What is the probability of the stock price rising? Only the pure probability you just calculated, that is 68%, 70% into 80%, 56%, and 30% into 40%, that is 12. So 56 plus 12, you just calculated it to be 68%. If you solve this, you will find the probability of market rising given the stock price has risen. And that's it. In the CFA FRM and actuarial examination, this is what you need to know for Bayes theorem. Actually, Bayes' theorem is not only related to this. So, if you're interested in like deep diving into the Bayes theorem, understanding what is the prior probability, what is the posterior probability, what is the new information, what is the old information, which is a very intuitive and good concept to know about the Bayes theorem, just chat in the comment that you're interested in knowing about the Bayes theorem in detail. That's it. With that, we'll end the session here. Thank you. Have a nice day.